All right, sweet. So, to give an example, that's my desk. Area on, let's say 2, because it was a bit more difficult. Actually, I'll go do 4, because it was probably one of the more difficult. Since they gave us the diameter, and this was, I believe, last night's, the remote control and the TV. They gave us the diameter. We have to figure out the radius, and that would be 9.4. Then, likely on a piece of graph paper, because there's not like any extra space on this paper, but I'm going to grab a Post-it real fast so I can do my work right here. Guys, I'm pointing out the main mistake that I've seen people make as I work with them. The pi is not part of getting squared. Just the radius is. So when I replace pi with 3.14, and then replace my radius with the 9.4 that I found it to be, when I go to do that in my calculator, the first thing I'm going to type in is 9.4 and then hit the little button to square. Or you could just type in 9.4 times 9.4 because that's what squaring does. Then I'm going to take that answer and multiply by 3.14 because that's our pi value. So 277.45, I find that rounded, right? So 277, probably 0.5, haha. And the directions on this one, write the letter of the answer in the circle that contains the exercise number. So the letter N was my answer for number 4. So I go down to the bottom, and number 4, I should put an N inside of it. Does that make sense? Questions on how we're doing these worksheets? We will talk about the answers to these tomorrow, talk about the punchlines, right? Like the answer to the joke of what happened when the remote, or when the TV set asked the remote control for a date. I think the answer is going to be April 7th. Because it's today's date. It's okay, I'm not funny. I get my kicks on not being funny. All right, so Desmos, when he asked for a date, but the date is April 7th, as opposed to a date, like go out to dinner. I like how some of you now are like, oh, yeah, no, not funny. It's funny to me how not funny it is. All right, where did I go? You're looking for Dandy Candies is our Desmos activity. So if you can't remember how to log into Desmos or you get stuck, raise your hand. Sometimes we do get stuck in that weird loop, but you are logging in with Google. You are logging in with Google. Dandy Candies. I figured we've done a lot of like worksheet and highlighting notes and stuff like that. We needed a fun activity. I got Vincent. I got Layla. I got Carmen. I got Layla. I got John. So I got both Laylas. Ooh, a lot of people hopping on now. All right, I'm going to walk around, pass out papers, help people log in if you need it. You're going to Dandy Candies. Dandy Candies. Make sure you log in with Google. So you got to click sign in and then log in with Google. Oh, you shouldn't need it. Yeah, we did today. Is he on a trip? I don't know where he is. Nice and convenient right on top of your hands. I'm feeling dandy too. He's feeling dandy. Click login with Google. You're logged in. So then go to click on that, or scooch down and go to Steam homepage. That. Yeah, you can dive in. Once you're logged in, dive in. Are we good back here getting in? I probably have it in my hand right now. Oh, you have it there. Well, then you should need to see it. It's probably still missing if I didn't know it needed change. Yes, they were due last, and 8. They were due last week. 7 and 8 was due last Thursday. You said 6 and 7. But it's okay. Hey, where is it? Can you just show it to me real quick? I trust you. I just want to make sure that it is my mistake. Yes. 717, 718, they were due. So now you're a week late if they're not turned in. Like that, we need to fix. So that should be a quick fix. Yeah. If you come to me, we definitely can. You have to come visit me. I'm not sure. Most time, Desmos doesn't need sound. We can like look at it together if we want. Here you go. Let's just do this together then, so I can play the sound. Oh, what's it sound like? Hey, turn your speakers off if your speakers are on. Well, now my speakers don't want to work. We'll go back to you. Sounds like Willy Wonka. Foundations on language arts. I didn't put them on foundations. I put them on language arts. Yeah. It should. It works. I'll come over there because they're going to do Desmos, but it shouldn't.
I'll go pull it up.
Because yesterday it worked. I had kids after school here and it worked for them, but I can come check out what's going on. All right, so I got a situation to go take care of, I guess, with the Roman skits because I finally got them posted. So Miss Martin is in charge, unless you don't want to be in charge.
No.
I can put one of the kids in charge. All right, so just work on the Desmos activity. Essentially what you're trying to do is figure out how to wrap the same amount of candies in the least amount of wrapping, because that would be the most efficient. I mean, essentially I just kind of gave it to you of like what wrapping is going to take more or less paper or box or whatever you want to say. Right? So that's what they did. They wrapped it one way, they wrapped it another way. So it was the same amount of candies, right? The same amount of candies kept moving around. So guys, if you didn't pay close attention, it's the same amount of candies moving around. So each candy's in its own little container, but the same amount of candies get wrapped different ways. So same candies. I swear I was coming over there, but then we wanted to watch this again. So same amount of cubes, right? So really our question, what we should be thinking about is kind of like which arrangement makes the most sense to save us money on the shipping, right? Because we got to box it up and ship it.
I found the problem.
What is the problem?
There's also a link on the foundations page or something like that.
Yeah, are you guys in foundations when you should be in language arts? Because I can copy the folder.
No, I found it. I was looking at the foundations page, and it has a link for it, but I found it on language arts.
And does it? So yeah, let me double check that it works in language arts. I can put it.
No, it works. I saw it. Like the folder.
Gordon probably told me to put them in foundations, and I probably just goofed up.
Yeah, like you're able to like.
So click on that and make sure it runs. Because it should just be from the cloud. You're just watching it like. So I didn't upload them to YouTube or anything because student privacy. So you're in the drive folder because it should be anyone logged in with a Worthington email account should be able to watch these.
And then it's.
I'm still going to go over there with you because I want to make sure the ordering knows what's up, and then I'm going to teach her how to copy a folder if she wants to. I'll show her how to copy that folder.
I will have a feeling, but I don't know if it's an actual. Well, it could be. I mean, it's one of the 24 blocks. Be smart. Yeah.
All that.
What are you looking at, eh? Make sure you guys are working with each other, okay? You can ask questions with your teammates.
So after this, you can type a question if you have one, or we could just like type whatever and then we can go next. So if you don't really have a question right now, we'll keep in mind after the video. You can just go next. Yeah, that's so I have evidence of what happened when I left the classroom.
Yeah.
Ooh. He's smart. Maybe he's done this before. Well, I don't know if I would say I'm smart. I just am practiced. I like all of you guys saying like what the why.
Yeah, they had some funny answers. Doesn't make any sense. Tell her to see outside every single one. Just Andy for every response. I'm actually just gonna. Layla, you're not doing that.
All right, so some of you are moving through this a little bit quickly. So let's make sure that we're thinking about things. So I'm not going to pause the activity right now. I probably should, but I'm not going to. So the other day, now and also this I figured would help me clarify. We've talked about supplements, and people I think often think that's the same thing as steroids. It is not. So this is where my wife gets her nutrition supplements from, Bomar. And the box showed up yesterday, and it's not for me. I don't really take supplements. If you've heard, collagen is all the rage. So collagen showed up in this. But I got excited because on the front porch they left it upside down. And on the bottom of the box, it says 10 by 8 by 6. Anyone have a guess of what that 10 by 8 by 6 is? 80? Yeah, so it's the, what do we call that? The how big something is. That's how much space is inside of it, right? But if we're talking about like the length, the width, so I agree, if we multiply them, we're going to get volume. But there's a D word that talks about how big something is. The dimensions. So the dimensions are 10 by 8 by 6. John, you all right, man? So, if I look at this box, I could probably figure out which side is the 10. Which is probably the longest. Like this, right? Like compared to here, compared to the height. Like, so this is probably my 10. And do you think this is the 8 or the 6? How do you think the height compares with the depth of it? I think you're probably all making your own guess in your mind. I'm thinking this feels longer than how tall this is. And I know that based off how they laid the container in here. So if I say that this is 10 and this is 6, could we figure out the area of this one side? That's not a great 6. But if this side, if this face, we call this a face, if this face is 10 by 6, what's the area of a 10 by 6? 60. Could we figure out the top if it was 10 by 8? So now if we say 10 by 8, what would that area be? 80. So when you are one of these companies, you're buying the box. You're paying for the material that you're shipping stuff in. So that's what's happening with Dandy Candies. We're trying to figure out for the same inside, for the same volume, what has the best surface area. And luckily, the Desmos has everything split up into grids. So keep working, but like think and calculate. You can talk with each other while you're doing this and say, hey, what'd you get on this? But we want to try to figure out which of those packages uses the least amount of packaging. Right? And really, we can just go rectangle by rectangle by rectangle and think about every side individually. Go ahead and keep working, then I'll pull you back together to talk about something, kind of a shortcut. So I love statistics, and you're all anonymized right now, so none of your names are actually up here. I can guarantee to you these do not all use the same amount of cardboard. I can guarantee to you. So the funny thing is, most of us said that we think they use the same amount. That is not true. They all have the same volume, and that's the trap door. They're all wrapping up the same amount of candy, but they don't all use the same packaging. So you don't have to go back and change this answer, but I am telling you, this is not right. So keep working. So do not tell yourself they use the same amount. They don't. Who needs help? I want to do math. Who wants help? I don't think we're going to go ahead. lot of us have moved on from slide 4 too quickly.
So now,
Actually, everyone who has moved past slide 4 has it wrong.
so now,
So go back to slide 4.
how much is and how much fiber will it take to make each box? So you see all these little boxes behind it.
All right, we got to talk. Because everybody's getting this wrong, so this is on me. Right, we got to talk. So I need to pause it because I need your attention. If you don't have graph paper, get it. If you don't have graph paper, get it. We're going to test my artistic ability here. We're going to label this paper surface area. Because I did not put a very good section of notes in your notes packet. I realized that after I copied them all. If I have a box you do not have to try to draw a box on your paper, but you can if you would like to. The trick is all the lines that are going away should all be parallel with each other. And then this should square up the same as the front square to make it look kind of three-dimensional. We have a width, a length. I don't know, I'm writing red. I don't love that. A width, a length, and a height. It's like my Bomar box. And you said that the front of it, we could just do 10 times 6 and get 60. So that, I think, is like width times height. Right? Width times height. How wide is my box? How tall is it? So for one face, I'm going to say face F for front. For one face, we did width times height. Would there be another chunk of cardboard on this box that is the same? Aiden's shaking his head yes. Explain, Aiden.
So the other's like the opposite side of it. Like the
The back of it would be the same. So the back of it, face B for back, would also be width times height. So these are the same. We got two matching faces. We call these faces. What about the, if I look at the box, what about the right side? We said, so the right side, I might shade this a little bit. That was our front. This was our back. So now if I look at the right side over here, and I know my picture doesn't match this box, but we would do the, up here, what do we call it? The what times the what? The length times the height. And would there be a side that matches the right? The left, right? The right and the left are gonna be equal. So the left is also length times height. Well, that's interesting. And then what haven't we done? We did front, back, right, left, top, and bottom. So if I look at the top here, what dimensions am I going to multiply? This was length times width. And the bottom's going to match. And here's the trick. I take this apart, it's just a bunch of rectangles, right? We literally, it's 6, right? It's 6 rectangles. But watch what happens. And if you're still writing down, that's okay. But if not, please give me your eyes up here. 2 times W times H, right? 2 times the width times the height. 2, because there are 2 of them, times the length times the height, and then 2 of the length times the width. How many times do we use each variable? Twice. So with our numbers like I have with 6, 8, and 10, these are nice numbers. So if I'm doing this with 6, 8, and 10, it's not bad. If we write out length is, what are we saying? Length is 10, the 8, so 10. Width was 8, and height was 6. Go ahead and put this on your paper, or these can be equals. I don't know why I'm using colons. Just watch real quick. The surface area of a prism, meaning a box. Fancy name for a box is prism. We'll talk about more prisms probably tomorrow because I don't have much time today. Is 2 times, take your first 2 variables, 10 times 8. Plus 2 times, take the next 2, 8 and 6. Plus 2 times, take the only 2 we didn't pair up yet. The 6 and the 10 are the only 2 we haven't paired up yet. That is how we find total surface area. Front matches back, top matches bottom, left matches right. So we can just double each of them. So if this is like the top, it also takes care of the bottom. If this is like the right side, it also takes care of the left side. If this is the front, it also takes care of the back. Kylie, you good? I can't see you because your water bottle and everything. So I'm going to unpause the activity and see if we can go back into slide 4 and think about that. Now that we can kind of see, oh, it's showing us how big things are using those cubes. So it says drag the points to arrange the candies. If it helps with your thinking, then enter your answer. So they give you the length, the width, and the height. You need to do what we just practiced. So you probably got to write a couple things down because that's some math, and that's some tough math. Yeah, we can do one of these together. Actually, I'm going to take a snapshot of this real quick. Color coding this to make it make a little bit more sense. Notice what I'm setting up. 2 times something, 2 times something, 2 times something. All added up. My first something, my first two dimensions. 24 times 1. 24 times 1. My second side, my next two dimensions, and that's why I color code it so you can tell 1 versus 1. And then the next face, I should quit saying side. The next face is the only two I haven't matched up. So 1 needs to match up with 24. I haven't used that 24 yet. With the 1. With the red one. This is how we solve out A. Take a moment. Try it out. I'm going to drag all that down a little bit and probably write out the work for D. So like there's your work for D. When you get to that point, if you want to look up here. You don't know yet. We need to solve some math to figure this out. So it's okay. I don't mind. I want to kind of bump it on to do the math. So if we think about how much cardboard it takes to make this one, how many squares are on this side? And then there's 6 on the back also, right? So we've got 12 so far. There's 4 here. So what's 12 plus 8? So I would write this stuff down as we go. Yeah. Should have made us all go back to slide 3. But I haven't done this activity in a while. Guys, I appreciate your patience with me because I am somewhat like frantically trying to fit in some teaching before the end of the year, especially if this is still confusing for you. Look back up here. This is slide 3, right? This will help us kind of, because you know my box is great. It's in the real world, but this might be a better visual. How much cardboard would it take to cover, or think about like wrapping paper to cover the front? How many squares? 6, which we know would also exist on the back. How much cardboard would it take on the right? 4. It's a little hard to see up here on my board, but also 4 on this side. And how much cardboard for the top of it? Yeah, 4 times 6, 24, and there's that on the bottom also. So top, bottom, left, right. And of course, I can't let you leave without oh no, I need my speakers to work for this. I should probably stop recording.